greetings to everybody who's joined on the line here. So as Lil mentioned in that generous introduction, I'm CEO and CTO of Nuvation Energy. And in my day job, I work on energy storage systems. This is one of our customer sites. And fun fact, my hobbies, I also build energy storage systems. So this is me welding inside of one of our mutant vehicles that we bring to Burning Man. And very much in the style of our self-expression of how we do things, it's a mutant electric vehicle. And so it's actually built around Nissan Leaf second life batteries, and that's what we use for the drivetrain. It's actually multiple vehicles. This one is like 15,000 pounds, so it's like a really large, like a parade float type thing that is fully run with electric power. This is the second of a set of 3 tutorials. So we are here inside of a battery warranty tracking tutorial. And the third in this set of webinars is on battery state of health measurement, and that will be December 16th. So here's the agenda of what we're going to cover today. So we'll start with a short introduction of Nuvation Energy. Some of you have attended past webinars and are now familiar with Nuvation. I did see some new people on the list as well. We'll then talk about why do we need battery warranty tracking. We will discuss battery warranty tracking as it pertains to an independent BMS. Nuvation sells an independent third-party BMS. And then I wanted to process some of the questions that people tend to ask us. So one is, how can I ensure my energy storage system stays within battery warranty? And then the flip of that is, well, what if I want to operate outside of warranty for an emergency response? We're going to talk about the cell to cloud data logging, the 3 different levels of data logging that exists inside of that. And then a little bit of interesting forward thinking of what's some of the cool stuff we can do now that we've accumulated all this battery data. We'll talk about planning for battery state of health aging. It is inevitable that a battery is going to age, so what should we do about that? And then we'll close with a little bit leading into the next tutorial, talking about state of health, which is how we measure if a battery is performing according to warranty. So a brief introduction about Nuvation. So as mentioned, we have offices in Sunnyvale, California, where I'm nominally based out of. Of course, at the moment, I'm speaking from home, but we have an office here in California. And then an office up in Waterloo, Ontario, Canada, which is about an hour west of Toronto. So we founded the company in 1997, been in business for 23 years. Roots of the company are in electronic product design. And in that business, we build electronic products to specifications for our customers. And we've done over 1,000 of them. And so we've worked in a wide variety of different segments, clearly a lot of energy stuff, but also video systems, military systems, medical devices, a lot of different products that we've designed. And then we started our BMS work inside of Nuvation Energy in 2008. And so back then, energy storage wasn't as common. You didn't get hundreds of people showing up for a webinar to talk about energy storage. So we've been doing this for a while, and now energy storage has really become mainstream. All the cool kids are here. And so it's a good time to be in energy storage and really see the amount of growth in the industry. So inside of Nuvation Energy, we do battery management systems. That's our core product. And then we do a lot of energy storage system engineering, kind of custom engineering services to make energy storage go. We also have an energy management system and custom variants of all of those. And then I'll highlight, because our customers mentioned it to us, that we offer really good support. Both field support and email and phone support, and all of our engineers are based in US and Canada. Inside of our BMS products, we've got 2 main family lines. So our high voltage BMS goes up to 1,250 volts. That is our Gen 4 BMS. We're currently working on our Gen 5 BMS that will go to 1,500 volts. And then our low voltage BMS is for 60 volt and under applications. And so this goes into applications such as telecom, forklifts, robots, RVs, and systems like that. A lot of our engagements with customers are a combination of a product sale and energy storage system engineering. And so here's examples of some of the system engineering services that we offer. So we do full system engineering down to the cell level, all the way up to containerized energy storage systems. So customers often ask us to research and select a battery or PCS that they'd like us to use for a particular system. And for us, it's kind of a cafeteria menu of energy storage system engineering. So when we get into a conversation with a customer as to what they'd like in their energy storage, some of them have already selected a battery or already selected a PCS, and we incorporate that into the design. Other customers are just starting with a clean slate, and we can work with established battery manufacturers and PCS companies with which we have relationships. We can do custom rack and container design or selection. So these photos on the left there, that's a custom 24-foot container that we designed for one of our customers. And this one had particular siting requirements that required a really dense design. It's a 4C high power system, so this battery discharges in 15 minutes. We can do design for certification. In fact, that's one of the services that we offer. We've had multiple battery manufacturers that hire Nuvation in order to take their battery with Nuvation's BMS through UL 1973 certification. That's one of our services. Energy storage design involves thermal management as to how you're going to do this, air cooling or liquid cooling. And then very much in line with this webinar, we do data logging and analytic solutions. We also have an energy management system. And so depending on the application, sometimes a customer already has an EMS, sometimes they've developed in-house, sometimes they've selected another one, totally fine. We have other customers that ask us in order to do the EMS for them, and we're happy to do that. So we have an EMS that does demand charge management, a lot of renewables integration, so things like PV smoothing. We do a lot of microgrids. This is a good example where the custom engineering comes in, because microgrids, you've got a lot of site controller work in order to hook in the various different power equipment that's on that site. And we commonly call that the site controller. So that's the communication between, the BMS, the EMS, the power meter, the PCS, HVAC, all that sort of communication. The site controller is kind of the device driver layer for energy storage. Nuvation is up over 130 installations worldwide. So certainly a focus in US and Canada, because that's where our offices are based. And then through our customers, we've got sites, all over the world. And so it's exciting to see our sites show up in different locations. We've got a number that are actual island installations. So like the island of Lufika, we're running the whole island in the Kingdom of Tonga. We've got a site on an island just off of Panama. And so we get to work in a lot of different locations. A little bit on Nuvation's architecture of our products. And so we've got the 3 layers of the BMS. So it starts at the module level BMS. We call that our cell interface. And so it's sitting directly closest to the batteries. It's measuring the cell voltages and the temperatures and doing balancing. We then have the stack level BMS. We call that our stack switchgear. And it's built around our stack controller. And that's really the brains of the BMS. So it's doing all your state of charge and state of health algorithms. And this is the layer of functional safety. And it's combined then with contactors, fuses, and current shunt, all the things you need in order to implement a stack level BMS. Above that, we have our system level BMS. We call that our battery control panel. And this is our multi-stack controller. And so it combines data and control from up to 36 different stacks, so you can interact with it as a single unified battery. And then depending on the application, above that we may have an EMS. We call that our end controller. To look at that graphically, you can see the cell interface sitting closest to the battery cells. That runs in a daisy chain stack up into the stack switchgear. Then the stack switchgear are put in parallel, and the communication is routed through the battery control panel. One of the advantages of working with Nuvation's BMS is the high level of battery flexibility. And so we have dozens of battery manufacturers that we've now worked with our BMS, all the lithium chemistries, a lot of installations that are NMC and LFP, A lot of installations that are lead acid, either 2-volt cells or done as 12-volt monoblocks. And then because our BMS is so flexible, we get into a wide variety of other applications, such as zinc and LTO and blue Prussian and supercaps and all kinds of different energy storage systems that need managed. The advantage of this with Nuvation's BMS is you can move between any of these different batteries, and the BMS being configurable simply manages that for you. And so what we hear from customers is changing battery manufacturers using the battery manufacturer's BMS can be a fairly large engagement where there's system engineering that's measured in months or even quarters in order to integrate a new BMS. With Nuvation's BMS, you get total flexibility in your battery supply chain because you can move between different battery manufacturers. And for us, it's as simple as just loading a different software configuration file into the identical hardware, and it maintains the identical interface to higher level systems. So the higher level systems, such as your EMS or SCADA systems, the battery is fully abstracted from them. And so this makes a lot of things in the field easier. So you can combine stacks from different manufacturers. It also makes augmentation a whole lot easier. Nuvation's BMS is recognized under UL 1973 and UL 9540. The key advantage of this is when you go for UL 1973 certification of a stack, the majority of the testing is on the BMS. So given that our BMS is already recognized, it radically accelerates that schedule and reduces cost. So UL will often speak that a from scratch BMS and battery is in the range of a 6 to 8 month schedule process. With Nuvation's BMS, it's less than half of that. So often I like to start with why. So why do we need battery warranty tracking? So as we all know, as batteries are used, their performance reduces. There's really two ways that happens. There's what's called energy fade, where the usable storage capacity of a battery decreases. And so over time, you have less energy storage inside of a battery as the battery ages. There's also what's called power fade. Power fade is the cell impedance increasing in the battery over time. That reduces the total power that can be drawn from a battery. More of the voltage drop and more heat is generated in the process as your cell impedance increases. So what this means is a battery warranty covers more than just the functionality to charge and discharge current. So when we talk about warranty in most of our lives, we basically mean is the thing still work or not, right? So if you have a warranty on your toaster and the toaster doesn't toast bread anymore, well, it's broken, and you take it back to the store and get a replacement. Batteries, it's a little different because it isn't that the battery is just broken and doesn't work. It's actually the warranties are written as the level of battery performance versus the original nameplate capabilities. And so it'll be written as a function of state of health. So let's compare this to a car warranty. So a car might have a 50,000 or 100,000 mile warranty, but how that car is driven has a huge impact on how much wear the car accumulates per mile. So you'll hear, highway miles are a whole lot easier on a car than city miles. Highway miles, you're running on smooth roads at a fairly constant speed, whereas in city streets, it's a lot of start and stop and potholes that are much harder on the vehicle. So this analogy is very true for batteries. How the battery is used significantly affects how the battery ages. So typically battery manufacturers will write warranties as a cycle life to a state of health. So for example, we'll say, hey, this battery has a warranty of 3,000 cycles, and after 3,000 cycles, you'll be at 80% state of health or better. However, that has to be within certain given operating parameters. So for example, there'll be a state of charge range. So it might be 100% depth of discharge, but more commonly, it's some subset of that. So it might be, we're going to charge to 90% and we're going to discharge, leaving a residual of 25%. Temperature is one of the most important parameters in battery warranty tracking. Heat can rapidly age a battery. And then the power level, which is really the current going through the battery. And this is often expressed as the C rate. And so you heard people talk of like a 1C battery. 1C means that it's a battery that's fully discharged in 1 hour of time. A quarter C battery discharges in 4 hours, and we're seeing that being pretty common in solar applications. And then a 4C battery, like that one I showed at the start, is a high power battery that actually discharges all of its energy in 15 minutes. So all this to say, battery warranty compliance and claim verification requires tracking a whole lot of battery data and operating parameters so that we know how the battery is used. And what we've seen is that in large sites, the end of life of a battery is really determined by simulation of the specific way the battery is going to be used in that site, like what's the energy profile, and then that's a business agreement between the parties involved. Let's talk a little bit about battery warranty tracking using an independent BMS. So Nuvation's BMS works with virtually any battery chemistry and any battery manufacturer. And because that's a little different than a BMS showing bundled from the battery manufacturer, I wanted to say there's 3 different ways that can show up. So one of them is, our largest customer base is battery manufacturers, and they come to us and they select a Nuvation BMS, and then they sell that as a bundled solution to you. But you'll get the battery manufacturer's battery, and you'll get Nuvation's BMS, and it shows up as an integrated system. The second way is system integrators select the battery and BMS separately. They want to have the best battery and negotiate the best deal on that, and they want to have the best BMS, and so they select those parts of the system separately, analogous to how you would select a battery and a PCS differently. The third approach is we've seen a number of operators that specify the BMS in their RFPs such that they can get the BMS performance that they desire. As mentioned, in all this process, an independent BMS abstracts the lower level battery details. And so across different chemistries and different battery manufacturers, you have a unified interface to the EMS and SCADA for virtually any battery. And in case anyone isn't familiar with this approach, I often mention that this is a very proven and accepted business model. It's becoming very common in stationary energy storage, and even before it became a thing there, this is the standard in the automotive industry, that battery manufacturers focus on batteries, and BMS companies that specialize in electronics and software show their expertise there. So what's interesting in this approach is that using a third-party independent BMS, you get increased transparency and accountability. So a good analogy on that is that in financial systems, an independent third-party audit is definitely considered to be of higher credibility and safety for investment than the financial records generated directly by the company. So if you think about that, it's the same thing with a BMS inside of energy storage. Using an independent BMS for battery warranty tracking provides accountability in both directions. Battery manufacturers get third-party transparency on how the battery is operated. So if they get a warranty claim, they can look at the data and know that the system's been used within warranty. And operators get third-party transparency on battery health and performance. And so they get, full detailed information on how the battery is performing. So people ask, how can I ensure my energy storage system stays within battery warranty? So Nuvation's BMS is functionally safe, recognized BMS under UL 1973 and UL 9540. And within that, we have lockdown zones where it gets locked down in the process and can't be unlocked as to what the operating limits are for voltage, temperature, and current. Now, because it's configurable, you can pick that those lockdown points could represent the chemical limits of the battery and thereby be used to prevent unsafe operation. Or you could use those lockdown points in order to represent the battery warranty and use that to prevent operation outside of warranty thresholds. Most BMSs on the market are fixed function, and so they're locked to a specific chemistry or battery topology, and they don't offer this kind of configuration flexibility. Now, since we've discussed that the system can be locked down to stay within warranty limits, we often get the question the other way. Well, okay, What if I want to operate outside of warranty for an emergency response? And I very much get this world. My personal anecdote on this was I used to drive a Nissan Leaf, now a Tesla. And when I was driving my Leaf home, being an energy storage guy, I often push the limits of systems. And so I would routinely drive the Leaf down to its bottoms. And one point it was already in turtle mode, and I was 0.8 miles from home, and I was like, yeah, it's flat, I can make it. And and it completely died on me on the side of the road. And so I'm sitting there on the side of the road, and I'm like, you know what? Dang it. I know that I still have 30% state of charge in this battery, because that's the reserve that Nissan keeps. I would happily trade any amount of warranty to get just a little bit of energy to get 0.8 miles home in charge. So these sort of things happen. The advantage with Nuvation's BMS is you have that performance flexibility. And so an independent BMS offers you that emergency response operation. Our belief is that the BMS exists in service to the customer that bought the BMS. So at the discretion of the customer, you could lock the BMS down to functional safety limits of the battery, or you could lock it down to the energy storage ranges of the battery warranty, or our BMS can be reconfigured real time without even going offline to permit emergency operation to a deeper depth of discharge, or a wider temperature range, or higher power. In such a mode, then battery warranty tracking observes and records what's going on, but it doesn't get in the way. There might be a battery warranty cost to this, and that's really a business conversation to work out what that means. But fundamentally, the customer gets to say how they want to use their energy storage system. So my business example on this is I was talking with the CTO of Italy, and she related that they had an issue in Italy where there was a frequency regulation event, and the frequency dropped slightly below 60 hertz, and they're discharging their Samsung energy storage systems in order to correct for that. And then the containers hit their 30% state of charge barrier, and they all went offline. And this was in order to honor the battery warranty. And she was furious. She's like, I don't care about my battery warranty. I have a country to run. I own these energy storage systems. They are my asset. I should be allowed to use them how I want to use them. So with Nuvation's BMS, you can do that. Let's talk about cell to cloud data logging and the different levels that exist inside of that. So there's 3 levels. There's the stack level, the system or energy storage system level, and then there's the cloud level. So why are there 3 levels of battery warranty tracking? Well, the first reason is cost of storage. So higher levels are more cost effective in order to store data. So the most expensive place to store data is in the embedded systems that are functionally safe down at the stack level. So that means that what is stored at the stack level is not full data logging, but it's usually aggregated data. So it's like histograms and quantized odometers. At the system level, there's usually like a ruggedized computer, and storage is more cost effective. And so this results in storing data logs. Though typically there isn't enough room there to store full 1 hertz information for the life of the site. So usually it's decimated information. And so you take the 1 second data for a while, and then you'll decimate it down to minutes, and then sometimes decimate it down to hours. Inside of that decimation, typically you see that you keep the min, max, and average, so that you keep those limits of what happened inside the system. And then the highest level, cloud storage, is really the lowest cost. And so the advantage of cloud is you can store all the battery's data, as much stuff as you want, 1 hertz intervals, really for the life of the site. The next reason why you have different levels of warranty tracking is for internet resiliency. So you can't rely just on the cloud storage level, because if you have a break in your internet connectivity, then you need to have that local system storage in order to queue that data. And then the other direction is that you need data backup. And so, common IT practices is you use offsite cloud storage to back up any local storage. Energy storage does exactly the same thing. So you have to have that cloud storage to back up your local system data. So in the event of an unfortunate site level thermal event, that local storage could be compromised. And so just like an airplane black box, an operator would definitely want those detailed battery warranty logs backed up and available offsite. So let's talk through in a little more detail each of those three layers. So in the stack switchgear, you want the visibility to track over and under cell voltage, over and under temperature, over current situations, over and under stack voltage, and then the energy throughput, as we call it, which is a variant of cycle count. So you want to measure the amount of energy that's moved through a battery, because that's what causes most of the aging. Within that, we want to store the all-time, lifetime maximums and minimum values, and we do that with the index. So what I mean by that is that you'll get like, my highest ever cell voltage was 4.3 volts on cell 7 in stack 9, tray 4. So it actually gives you that level of detailed information. We also keep a count of the accumulated time in each of the quantized buckets. And I'll talk about that more on the next slide. And then all of this is done in non-volatile local storage, meaning that it's protected from sudden power loss. And so at any instant, you could lose power at the stack level, and all your data is stored in non-volatile storage. So what I mean by battery odometers is you can have all these different quantized buckets. And so ideally you want to be in these green regions where you're either idle or charging and discharging within standard currents at standard temperatures. However, you might have a system that allows you to go slightly outside of that. So for example, say it's warranted as a 1C system, there might be the ability to go to 2C for periods of time, and it simply consumes the warranty at an accelerated rate. Same can be said for temperature. You're supposed to stay at a standard 25C. It might be between, say, 30C and 45C. The battery is still allowed to operate. It just consumes the warranty at a slightly accelerated rate. Beyond that, in any of these red regions, the BMS does its job and takes the energy storage system offline in order to protect the battery. And then inside of this, you can have more buckets if that's what's desired or that's what the business agreement is. So you could, have, a dozen different buckets in which you measure temperature or in which you measure current, whatever the requirements are of that specific battery warranty. Going up to the system level, in Nuvation's products, we call this the battery control panel. So this is now local data logging at the energy storage system. This gives you short-term 1 Hertz data, but then decimated for the longer term. As mentioned, it offers system resiliency to internet outages. And so the data is queued inside of the battery control panel. And when the internet link comes back, then it streams that back up to the cloud. Our BCP is equipped with a cellular link. So should the local network fail, it has a cellular link in order to provide parallel communication. And this enables capabilities such as BMS alerts. And so we have a system that can send texts or emails for warnings, faults, or warranty events. Just to show the kind of data that you'd see captured at the system level, it's really the kind of information you would expect. All your stack voltages, currents, powers, charge and discharge limits, any faults or warnings, the connection status, and then your cell temperature per individual cell, max, min, and averages, and your voltages, max, min, and averages per cell. With all this data at the system level, it also enables visualizations. And so this is captured from the touchscreen that we have on our battery control panel. And you can either have dashboards that are customized to the site, or you can have visualization views where you can zoom in and out and look at individual data locally. System level also provides for download logs. And so from the system, you can attach to it from a computer and download whatever logs you want. And so you basically get like a CSV file that you can then drop into different systems for further analysis. And then the third and highest level is the cloud level. This now brings in the power of cloud computation, storage, and communication. You can store all full 1 Hz data persistently for the life of the site. Even if a site is repowered or augmented, you can continue to store the data. It provides that key feature that the battery data is backed up and remote from the site, giving that sort of black box of an energy storage system. And it also opens the opportunity for advanced battery analytics. So that's kind of cool. So what else can we do with all of this battery data that we have? So an example of that is remaining useful life calculations. So a lot of customers ask about this. So state of health is really the current health of the battery, and that's based on capacity and resistance of the battery. The remaining useful life is the predicted or estimated time to failure. Inside of this, you have to pick like a state of health threshold. So what is the point at which we say the battery is depleted? Is that 80% state of health, 70% state of health? And the same thing on cell impedance, is you pick a threshold, which is the declared point. And what's fascinating is the same data that we're already using for battery warranty tracking can also enable all of these advanced cloud calculations. To quickly cover how that calculation is done, what we'll do is take data, feed it into a neural network, and learn the typical degradation curves based on past operating conditions. And so you'd see what your battery looks like and the curve that it follows down to your state of health threshold. Then on another system, you would train your remaining useful life algorithm. And once you have enough data, then you can start making predictions as to what this battery will look like down to its state of health threshold. This would usually be done with cloud computing, and so feeding in information like your voltage, current, temperature, cycle count, how the battery's operated. Then one can get outputs of resistance and capacity, which can feed into state of health measurements. Another thing that we can do with cloud computing and all this battery warranty data that we have is we can run model-based simulations versus measured data. So model calculations are pretty complicated, and so it wouldn't make computational cost-effective sense in order to run that down at the embedded level of the BMS on site. But in the cloud, processing power is much more cost-effective, and so we can actually run these pretty advanced models. And then we can look at, is the battery degrading at the expected rate? Is it degrading faster, slower, differently? And because it's cloud computation, it's easy to update those models. And so our battery models continue to get more advanced. And so we can run continuously improving models in the cloud. We can also do battery life optimization. And so with this level of detailed state of health information, we can actually tune the usage of the energy storage system to extend the battery life and achieve performance beyond warranty minimums. So we can think about like big data analysis, comparing cells. So if we look across millions of battery cells on multiple sites and run big data AI algorithms, we can identify and resolve any emerging issues. So you can see little subtleties in the data that are well within operating ranges, but they can highlight soft issues and allow them to be corrected ahead of system damage. So personal example of this is we have one of our test systems is an electric race car that we built back in 2008 called EREX. And it's got 104 cells in it. And early on in the testing, we noticed there were 3 cells that were slightly lower voltage than the others. Not by much, 5-10 millivolts, not a big deal. But as humans paying a lot of attention to an early system, we could see that. Then over time, that 10 millivolts became 20, and then 50, and then 100, and eventually those cells failed and had to be replaced. But this tends to be what batteries do. It's pretty uncommon that batteries just suddenly catastrophically fail. They tend to age fairly slowly, and that can be observed. Now, inside of a 104 cell system, a human can notice a few cells that are different. But when you have millions of cells in a system, then computers are much better at that. So looking at the data, computers can notice, for example, slight temperature differences, which can indicate, asymmetrical thermal management, and heat definitely causes cells to age faster. We can also notice slight differences in cell impedance, which can give visibility into difference in your state of health power aging. We can even look at things like balancing times. And so cells that require more balancing time is indicating a variation in cell-to-cell coulombic efficiency, which is again indicative of cell aging. So this enables services such as fault prediction and preventative maintenance. So we can actually correct a predicted fault as routine preventative maintenance. So rather than, like in that electric car example, rather than waiting until those cells fail, we can see them aging and then do preventative maintenance and stay ahead of a fault that actually takes an energy storage system offline. We can also run cell replacement service algorithms. So we can be paying attention to cells that are aging at different rates and predict which will require replacement first. And then we can look at the cost of a truck roll and the labor in order to do replacements and feed that into a financial algorithm to determine should we be doing replacements at the cell level, at the module level, the tray level, or maybe full stacks, or maybe in full containers. There's different ways that these calculations can be run. Another piece of battery analytics that we can do is called sense wire conductivity. So this is a proprietary algorithm that Nuvation developed in-house. And what we do is we test and rate the relative impedance drop on the different sense lines of a battery. And what we've discovered is that we can actually learn some really interesting things of what's going on inside of the battery and the module when we do that. So this here is some captures of one of our field systems. It's got over 5,000 cells. And we ran our sense wire conductivity algorithm, and we got this output data here. And it sort of looked like there were three groups. We fed it into an unsupervised learning k-means clustering algorithm, and we got these distinct graphs. So it was fascinating. There was one group that was caused by the particular design of the battery module. So basically, cell index 1 had a stronger conductivity. Most were in this blue group. And then there were 48 cells that were in a distinctly statistically significant different group. We're like, well, that's weird. So we reached out to the battery manufacturer to ask what that was about. And they actually said, oh, okay, thank you for finding that. Turns out we had a manufacturing change during the time that your modules were being manufactured. And there were some bolts that were not correctly torqued at the module level. And so this was actually a manufacturing defect. So battery manufacturer was great about it. They came in, replaced the modules, absorbed the whole cost of it. Everything was good. But what's fascinating is looking at data and looking at analysis, we were able to detect this manufacturing defect ahead of commissioning. Had we not done that, it would have resulted in a situation where those cells would have run a little bit warmer and the cells would have aged faster. This same sort of data could be tracked over time, and one could actually get to identifying, for example, if due to thermorecycling, if your battery cells need to go in and get retorqued. So that's an example of the kinds of things that you can do with advanced battery analytics. So let's talk a little bit about how we can manage state of health aging. So we sort of accept that it is inevitable that batteries are going to age. And so what do we do about that? As commented, we can design to extend battery life. So we can do things paying attention to state of health information. Maybe we operate at a subset of our operating ranges of state of charge or temperature or power, which will allow our battery to extend its life, last longer, get more financial value out of it. And then we also need to consider flexibility. So the example of the emergency response situation and how you can log into a system and do remote troubleshooting and reduce your maintenance efforts. At the same time that we're doing all this battery warranty tracking, We can also track the energy storage system at the system level. And so we can pull information from the PCS, from the fire suppression, from the thermal management system, and then we can overlay the battery warranty information on top of that. So if we get a battery that's running a bit warm, well, is that because the thermal management system is encountering issues, or is that because we've actually got warnings from the fire suppression system? And then another thing we should touch on is the design for future augmentation. So due to this battery degradation over time, energy storage system designers need to either select to over-design the energy storage system at the start, putting in extra batteries from the beginning to handle that battery degradation, or later in time, augment the system, adding more capacity in the field. So if you look at this financially, as battery costs continue to drop, it is certainly far cheaper to augment energy storage system in the field than it is to over-design it now. There's also a good cash flow calculation on that, that the cost of capital later is cheaper. However, in considering an augmentation approach like this, traditionally that creates a concern if the specific battery and specific chemistry that's being installed at the start, is that still going to be available 7, 10, 15 years from now? The advantage of using an independent BMS like Nuvation's is that augmentation is actually really simple to do. The BMS abstracts the battery manufacturer model and chemistry, and so the traditionally thorny issue of how to do augmentation is actually made really simple. All right, last topic, how can my BMS tell me if the battery is performing as promised? So this is really a preview into the state of health tutorial that's coming up next. And this being the last topic, I'll invite people to start thinking about questions they want to ask, because in just a moment, we'll switch to that. So another example of working with an independent BMS is it provides really increased detailed transparency of battery status. So for example, we offer per cell state of health and impedance information. So this is an example of our high voltage stack. This is one of our test systems that we have in Waterloo. And we ran our cell impedance algorithm on it, and it generated this histogram showing each of the individual cell impedances. And what was interesting was there were a few that were out here that were statistically higher cell impedance. And so it raises the question of, are those cells that need to be replaced? The answer to that question is typically handled by laying it against a graph and looking at the confidence interval. And sure enough, those cells are considered outliers because they're outside the 99% confidence interval. And so one could think about, does it make sense to replace those cells? What's the cost of doing that? What's the estimated remaining useful life on those? Is that something I should schedule in coming months or in coming quarters, or maybe I still have some years left on those? But you have that level of detailed information of how your battery is performing. So with that wraps up my talk. So that completes tutorial number 2 on battery warranty tracking. If you like that bit on the end talking about state of health, then you'll love the presentation on December 16th. This is made by Stefan Johannan, and he's a fabulous speaker. Always does an amazing job talking about some of the advanced algorithm work that Nuvation is doing. And so I know that will be a very engaging conversation. And with that, I'm available for questions.